I'm the chief architect at Etsy, and we're here to talk about Etsy's migration to Google Cloud.
Awesome. Thanks. My name's Danny Rosen. I am a technical program manager at Google. I worked with Etsy on the cloud migration. We're really excited to talk to you about it today.
So a quick introduction to what is Etsy. Etsy is the world's largest marketplace for unique and creative goods. We have a community that is over 2 million sellers, 39 million buyers, and we have 50 million items for sale on the site. We're also heavily diverse. 30% of our engineers are women, 4 out of 6 execs are women, and we have gender parity on the board. A lot of the Etsy sellers are also women. For the vast majority of them, Etsy is their only source of income, and their businesses of one. So we take all of that into account as we make decisions for the company. Thank you. So a little bit of background about Etsy. Etsy was founded in 2005. This was a time that the cloud did not exist as a concept. We were solely in the data center. And that in that time and era, we had to build a lot of our own tech because there was not much out there that we could use. You may have heard of a little daemon called statsd that was originally written by Etsy. We have a bunch of CI/CD tooling that we've open sourced, like Deploynator, and we have a fairly popular programming and engineering blog at codescraft.com. The reason that I bring that up is that we used to be data center focused. People who've worked in the data center know this timeline. You budget 3 to 6 months out. You order hardware. It takes some time to come in. Then you receive it. You rack and stack it. Then you provision it to set up all the software that you need on it before it can finally enter production. The timeline is really long. And Etsy was finding that this workflow was not scaling as the site was growing. And primarily, these are the 3 main benefits of the cloud. There is compute capacity, elasticity, and efficiency. Etsy is trying, the 50 million items that we showed are completely unique. They're not SKUs that we can easily search. So we needed a lot of compute in order to apply machine learning to figure out, for example, what are the items to show to our sellers, what would be the most compelling to them. And this was really hard to do it correctly and at scale and with efficiency in the data center. In Google Cloud, or in a cloud environment, we can spin up nodes really quickly without having to spend up front in purchasing the nodes and getting them ready to go. And the other thing is efficiency. For Etsy, the traffic follows a sort of pattern that peaks in the day and then slows down at night. We are burning a lot of compute, keeping those boxes running 24/7 in the data center. In a cloud environment, again, this is not a problem. When we don't need the nodes, we turn them off. It's efficient both from a cost perspective and also an environmental perspective. So why Google Cloud?
It's a good question. Why Google Cloud indeed? So I think there are 4 major aspects of why Etsy chose Google Cloud. The first is culture. Google's culture and Etsy's culture follow a really interesting connectivity that we're going to talk about in a sec. The second is there's a focus on ML. And that if you haven't figured that out already as part of our marketing narrative, it's really clear in the products that we're pushing out and in how Etsy is implementing. It's pretty interesting. Finally, third, international data centers. There's a long list of data centers we support, and it works for Etsy's global footprint. And then finally, we both have a really strong commitment to sustainability, making sure that we're taking care of the earth together and making the right decisions for ourselves. So we say culture, and what does that actually mean? On the board, we have 2 different articles. The first is straight out of the SRE book about postmortem culture, right? This idea of being blameless. A while ago, a person named John Allspell from Etsy actually wrote one of the major pieces of this in Code as Craft that's referenced even today. And when you look at blameless and postmortem culture, you ask yourself, well, what's the big deal? Why is this important? And it's about iterative learning, right? It's about, hey, we made a mistake, and that's okay, because we're thinking for the long term as a collective, rather than for the short term for somebody to blame. The next thing is machine learning, right? So finding the right crocheted octopus on Etsy, kind of hard. How are you going to do it? Very hard. Machine learning, pretty clear. Notably, there are 4,444 crocheted octopuses on Etsy.com. Totally not kidding. This is not an edit, feel free. Yeah, so like if you need a crochet octopus, this is where you go. But Etsy's search engineering team, also represented in the room today, is actively looking at different ways of providing good search results that are relevant to queries that users are putting in. So searching for the word couch really brings up a couch, not a pillow of a couch. That's the idea. Next thing is international data centers, right? And there's so many on the board, and maybe one day a whole lot more as we grow. But this falls in lines with Etsy's global plans, Google's plans of expanding and having good partners that are tech-centric and building out in these different locations. And then finally, I think the thing that like is a little more emotional, but is relevant, right? Like, I have a family, and I'd like that family to grow one day and to persist. And if we take care of the earth and we're doing the right things sustainably with these big data centers using a ton of power, then like we're going to make sure that my family, your family, are going to have a better place to live in. And I think that as a community in tech, as we grow, the thing that at the end of the day we're using is power. We do so sustainably, and we think about the broader ecosystem. So that's why Google. Let's talk a bit about how we made this work and the partnership between the two teams. So it began in December of 2017, like in New York City, in Eric Schmidt's side office. There was a business conversation between lawyers, salespeople, talking about how are we going to make this work and what's the contract look like. And I'm sitting there chewing on my fingernails, oh, I don't know, right? And the right people in the room were answering the right questions, and we made it work. We started our partnership on that day in December. Weeks later, suddenly I find myself embedded as part of Etsy's team in their Slack, answering questions, talking about different technical approaches to building things out, and actually working out of their Brooklyn office once a week. Notably, Etsy has probably the best coffee in Brooklyn, hands down. So from there, we start to understand sort of their challenges or problems. As I'm embedded, I become part of the culture, and we start doing hackathons. One of the teams was blocked on some deeper details of Kubernetes, and we were able to say, okay, let's bring you into a Google office, get some Google subject matter experts on the floor with you, and actually do a Kubernetes hackathon. And in doing so, we unblocked a tremendous amount of work from their backlog that they had concerns about because they simply didn't have the background or experience. So we were able to knock that out right away. There are some other really interesting, notable things like Seth Vargo, who's one of our developer advocates, did a tech talk on Terraform. And he did it at Etsy. And it was so well done that it is now literally a piece of Etsy's onboarding education for their new engineers so that they know how to use Terraform. It was a Q&A session. Seth came and really provided a tremendous amount of assistance and depth because Seth used to work at HashiCorp. Yeah. And then finally, we did a lot of engineering and organizational cultural alignment. So, the cultures are tech companies. At the end of the day, we like technology, we like building solutions, we like figuring out the right problems. So there's a lot of good alignment there.
So, like Danny said, signed the contract in December of 2017, and we had a sort of hard deadline for shutting down our data centers about 20 months away. This was more or less like a leadership decision. We did not want to pay, we had signed a commit with Google, we had a data center footprint, and we did not want to have an extremely long migration where we're paying for two things and sort of doing things slowly and iteratively over N years. We felt that we could move a little bit faster, and I'll explain more of that as we go through the talk. So we essentially had 20 months, but 4 of those 20 months were the busiest period of Etsy. It's the holiday season. Etsy is a shopping platform, and that is our biggest quarter. We try not to make large infrastructural changes then, just to avoid instability for our users. So preferably, we would prefer that the large portion of the migration finish in the first 8 months so that we have the other 8 months as a fallback in case we need to fix some things or have a complete do-over even. So just to remind you of the ground rules that we set for ourselves, no large architectural changes. This is primarily because we felt that doing a rewrite would add a tremendous amount of risk to the project. Etsy, like I said before, has been around since 2005. The code base has a lot of kinks in it. It's legacy, if you would be okay calling that. And we did not feel that we had the time to sort of rewrite it into a sort of microservices architecture in a way that would make it that would stick with our timelines. The other thing was to migrate the fewest systems needed. Like Etsy has been around for many years. We have lots of systems, a lot of supporting systems, and we wanted to see what is the minimum set of systems that we can migrate in order to run Etsy.com in GCP. And thirdly, like to stay compliant, like we're a public company, we had to comply with a set of regulations and rules that we could not sort of break. So this is roughly like the timeline that we came up with. Start the partnership, set up a squad, do all the work to get there, and then cut over by August, and then do some tuning. If everything goes smoothly, then like by the time like Thanksgiving hits, the site is running in GCP and is completely stable. So Danny briefly touched on the partnership aspects. I'm just going to skip forward to the migration. So Etsy's infrastructure is made up of a bunch of teams. Like they own their own systems, their own roadmaps, and their own tools. And this creates a problem for a project as complicated as a migration, because the migration throws a wrench into everyone's plans. We did not want to disrupt all of these teams from doing what they were doing, which was really mission-critical stuff for Etsy.com. So instead, what we came up with was a migration squad. We took one or more people from every one of those teams. We took away all of their other responsibilities and focused them solely on this task of moving Etsy.com to the cloud. This allowed them to basically like not get distracted by day-to-day stuff. Like Etsy.com was still running in the data center, which meant that there were still things that needed to be fixed, issues that came up, site outages and stuff like that. But they did not have to focus on any of those things. They were solely working on the migration. So once we had the squad set up, we had to figure out how to work with like the tools in the cloud. Etsy, as I'd alluded to before, had a bunch of custom in-house tooling to manage things in the data center. For example, to provision a box, like we wrote our own tools. It is open sourced, but it was written by us to manage the sort of various permutations and combinations of hardware. In Google Cloud, this was not a problem. Like we had to pick a tool, we picked Terraform, but we had to learn how to use it. Google was, again, a great partner. Like Seth Vargo came on board, taught us a lot about how to correctly do Terraform at scale. But it was something that we had to learn and figure out. Another example of this would be like learning how to use Stackdriver, or learning the sort of ins and outs of the Google network, if you will. So just to segue a little bit into the Etsy architecture. So we've been around for a long time. We're a LAMP stack. That was the hottest thing to do in 2005, Linux, Apache, PHP, MySQL. And because we've been around for so long, like we have a giant monolith. It's held together by our monolithic shards, and then Memcache is our primary caching tier. And the code is all sorts of tangles, which are really hard to figure out, and sometimes like causes some issues. But the good thing about the Etsy architecture is that the systems diagram is relatively straightforward. There is a load balancer up front that serves requests for, like, that processes the first, that is the first hop in a request to Etsy.com. There are some web servers that field the request. They further talk to some web servers hidden behind some internal load balancers, eventually talking to a database. This is an architecture that we were able to reason about really well, about the performance characteristics, the sort of what could go wrong. A pre-mortem was like really easy or relatively easy to do with this kind of architecture that we had. Thing over time that has been happening at Etsy is we've been also doing API-first development. We're, like I said before, we're a PHP site, so we don't really have the idea of an event loop, but we've emulated that by using curl. So let me quickly explain how that works. So this is, like, if you think of the Etsy.com homepage, there's a bunch of modules on it. So like a favorites module, a friends activity, or Etsy blog content, or promotions, or personalized content for you. So when you land on Etsy.com, it actually splits up internally into 4 requests for all of the different modules that I described, which may further break up into more requests to actually fetch the data from the cache or a database. And all of these are API tiers that are hidden away. The sort of nice aspect of this is it allows us to scale the system at every single layer without affecting the other layers. So like every single one of these is a web server and a load balancer, so we're able to scale up and down as we need and sort of reason about the system without needing to understand the full picture or having to worry about dependencies or sort of tangled, a sort of tangled tree of code. So how on earth do we migrate this thing to Google Cloud? Just to quickly reiterate, these were sort of our goals. And the way that we talked about it internally was maybe we can set up some read replicas. Etsy.com, simple application, why wouldn't a read replica work? So this is we discussed this internally for a very long time, but it came down to the fact that because of our monolithic shards, we had come to rely on some behaviors like immediately read after write consistency. This would be really hard to replicate if we were to spin up replicas of our data center setup in GCP that would be many tens of milliseconds away from the data center, which would mean that the consistency would not be accurate to within a millisecond or even within a single transaction. Another thing that we discussed was to maybe spin up active-active. So keep one copy of Etsy.com running in the data center and then spin up a completely active copy in GCP in multiple regions and redirect traffic maybe over GeoIP based on where the user is coming from. But again, the monolith and the sort of tangled dependencies made this really hard for us to do without having to do a rewrite. And one of our key goals was to not do a rewrite of the application. So what we ended up doing, or what we landed on, was a sort of lift and shift. As I had said before, the application we felt we could reason about reasonably well. So a lift and shift was actually a perfectly reasonable approach for where we were in time. Remember, we only had 20 months to migrate, and our application was a monolith that we did not feel we could rewrite in that period. But the problem with the lift and shift was that there is no clean way to switch traffic over. If you had an active-active copy, you could sort of bring all of them up and then turn one of them down. No one would notice. But with the lift and shift, that was really not an option. So we instead proactively communicated with our sellers that we're going to take a maintenance window. The site will be unavailable for a portion of time while we sort of migrated it to Google Cloud and brought it up there. This is not, again, anyone's first preferred approach, but we felt that given the constraints that we were under and the basically time, system limitations, that this was the best approach for Etsy. And being proactive with our sellers meant that we did not necessarily cause them any surprise. We didn't just go down. We gave them enough notice that this was going to happen so they were able to plan for it. So once we got all of the tooling, once we got comfortable with all of the tooling and sort of getting things spun up in the cloud, we entered the functional testing and the load and performance testing phase. So Etsy.com is a website driven primarily by load in the holiday season, so we had some expectations about that load. We made sure to test for at least 2x the traffic in GCP once we had all of the systems up and running. And basically, even if you're in the cloud, things that you focus on in the data center still matter. For example, CPU architectures. In the DC, all of our boxes were really custom. We had them tuned really well for our workload. And we found that we had to do some of that in GCP as well. GCP offers, at least at the time, 3 classes of hardware, 3 classes of CPU hardware. And we found that Skylake was the most performant for us. But it was not the default in the region that we were in. So as we did load and performance testing, we found this, but we were, again, able to tune it with Terraform to always pick the one that we needed. And it was a pretty decent, 10% win in the capacity for us. And at scale, even 99.9% might not be enough. So the Google Global Load Balancer at that time had a bug where at extremely long tail of requests, the latency would spike a lot because of some pod discovery. Google was a fantastic partner who worked with us on this. We told them we had an issue. They engaged us. They set up all of the packet captures at the various levels of the hypervisor to figure this bug out and fixed it. But this was, again, a thing that was a learning curve for Etsy. We were always in the data center. We knew we owned everything. So once the request entered our network, we had full control. And this was something that we had to adjust to. If there's an issue, how do you work with your partner to figure out what the issue is, and how do you remediate that? So a quick sort of segue into the most amazing outage probably of my career. So while we were setting up Google Cloud and a parallel infrastructure in Google Cloud to do all of this testing, we had staged the IP in preparation for the cutover. The way that we had done it was we have two DNS providers. One of them supports a do not serve flag. Basically, what that means is never serve this DNS record, no matter what. But the other DNS provider did not support a do not serve flag. So instead, we added it on into the provider with a load of 0, with a ratio of 0. What 0 means is run health checks, and if the other IP address is down, then you're OK serving this record. As it happens, after we had done this, Etsy.com had a small outage. For about 10 minutes, the main site was down because we were doing something, it didn't work. But what happened was we served the GCP test infrastructure IP to our customers. The good thing was that infrastructure was not scaled to handle traffic at the rate at which the traffic had landed. So it immediately fell over. But for a few of our customers, they saw a slightly unusual experience, like the colors were all wrong because we were using blue to signify that this is a test infrastructure, not orange, not the Etsy orange. So it caused some emails to our support site. But in true Etsy fashion, we celebrated this outage. It was completely unexpected behavior for everyone involved. And the engineer who was most proximate to it won the Etsy's coveted 3-arm sweater award for causing the most spectacular outage of the year. So moving on the timeline, finally coming to the actual cutover. We did all of the testing, functional testing, load testing, in order to gain confidence. And we realized that the only way that we would know if this would truly work was to send live traffic at it. No amount of testing can mimic the complexity of production, and the Etsy app is complex enough that we could not cover every single thing through simulation. So we felt that we had to at least cut over once to learn more about what are the hardest problems here that we have not found through basically that our engineers may not even be aware of. So the way that we planned for it was to have a soft freeze. This was a new thing for Etsy. We are a continuous deployment shop. We deploy 30 times a day. But in preparation for cutover, we communicated to all of our engineers that for a couple of days, things will be moving slower. So it would be a soft freeze where only P1 bug fixes would go out. And then we would enter a full freeze where no changes except those required to basically set up the cutover for success would be allowed. And then there would be a sort of period of heightened on-call monitoring. A lot of teams had signed up for rotations so that they would help observe the site once we were running in GCP. So
that was all Etsy's approach to the cutover process, a pretty different one. Google also had an approach. So I think the important context here is that Etsy ran their own data centers, everything in their data centers. So if any network issues happened, they had network engineers that knew what was going on. Now, Etsy is taking the responsibility of effectively running their data centers and giving it to Google. That's scary. So what we did to support them is we went in and masqueraded effectively as Etsy engineers, and we went through a 2-week immersed training in Etsy. Myself and a couple of other Googlers went in and then said, OK, we understand the lay of the land, how the systems work. We provided what we're just calling artifacts, right? We actually created system overviews, product overviews, and gave that to our support teams so that they had context on what to know if Etsy called and something was broken. Specifically for cutover, but hey, even after, they still have these artifacts, so they have some system archaeology and knowledge of state. Another thing that's important here is that Etsy has an interesting engineering culture, and Etsy in terms, right? And every company has corp speak, so we dock that down too in a glossary. So that's kind of one part of the work we did. The other part was we created what we'll call the war room, which basically was a cutover day team approach to connecting the Etsy team, us, who were actually on site at 3 in the morning, and the support teams that were monitoring. A couple days before, myself, a couple of others were on a gigantic email thread to hundreds of Googlers saying, Etsy is going live this weekend at 3 a.m. Effectively be ready. SRE teams, our product teams, our engineering teams all pretty much had an awareness of the situation. And we did it. We basically, we got on site. We came in numbers. There were 3 of us. And it was 3 in the morning, and we worked together to start the cutover process. Probably one of the most important factors here was that we had donuts. In having donuts, we were able to energize the team. So I wanted to thank specifically the sales team at Google for providing the donuts. Thanks, guys.
Cool. So cutover day. We picked a Sunday morning. It was 3 a.m. We determined that this was the lowest traffic time of the week for us. It would be the least impactful to do a cutover at this time because we had planned on being down for about 4 hours. So the rough idea was start at 3 a.m., turn off Etsy.com in the data center, do some validation and testing in GCP on the infra that we have there, and then slowly ramp up traffic to GCP, and then make a decision about whether to stay or not. As you can imagine, like turning off a website is not trivial. So Etsy.com has been like a continuously operated site for many years, and there are a lot of systems that are always running to make everything smooth. So like offline processing jobs, asynchronous jobs, big data jobs, database backups, all of these things that we had to plan for and execute in a particular, like in an exact series of steps in order to do it safely. Because we obviously did not want to lose any of our customer information, nor did we want our customers to see weird behavior on the site. So the way that we did it, we blocked them off at the CDN layer so that everyone who's coming sees a uniform experience that the site is down for maintenance. And then we worked with our databases, with our DBAs and other SRE-ish roles to like make sure that everything turns off in just the right order. And we did this. Like it took us about an hour and a half, exactly what we had planned for, but the site was down correctly and was replicated, and all of the data, more importantly, was replicated to GCP so that we could bring the site back up in GCP. So around 4:30 a.m., we did a cutover. Like the site was running in GCP, but only for internal users, only for all of our engineers who were there to test. And as these things happen, we ran into something that we had never run into testing. We ran out of memory on some key systems that only run on some key offline processing systems that we had not specifically tested. But they were important enough, as we found during the cutover, that we could not basically launch to our real users. It was also like 4:30 in the morning. No one had slept for the night. Everyone was really groggy, and we felt that we could not figure this out in time to make our window. So unfortunately, we rolled back. But this was good from like the way that we approached the problem, because we discovered something new. We discovered that we had not covered in enough detail an area of the site that we needed to do better in order to try this again. And why did we have to try again? Because of this. Like we had 8 months to do this right. We were already in August. And if we didn't do it in August, then we would have to wait 4 months until January before we were able to have another shot at this. So we felt like that if we were able to address the problems that we saw, that we needed to try again at least once so that all of the people who had worked really hard, like their work would pay off without having to wait for N months. Those N months could mean many different things. Like code would have changed in that time, infrastructure in the data center would have drifted in that time, and we would have had to sort of redo a whole bunch of things if we waited that long. So after like fixing and doing a bunch more testing, we decided to give ourselves another shot at the cutover. We made a couple of changes. We decided to start earlier in the night, so start at 1 a.m., and we gave ourselves a 6-hour window to do the migration rather than the 4 hours from last time. We felt that this added enough buffer that if we ran into issues, that we would be able to fix them. So we turned off Etsy.com. We had gotten really good at this point, having done it twice, like once off and then once on again. And we ended up finding new errors in the validation and testing phase. As an example, run some daemons that had too few threads, and this was causing some backups, some delays in critical operations. We fixed that. In another case, we had too many threads. And this was, again, causing system instability. But because we had set ourselves enough time, we were able to find and remediate these on the spot. And finally, like this time around, we were able to ramp up real users to the site. So around like 5:30 a.m., real users in the slow trickle started to see Etsy.com work in GCP. At which point we came, like, after we had been running in GCP for a few hours, like, this was sort of a key decision, which is, should we stay? We were learning new things, as I'll show in some slides that follow. But do we stay or do we roll back? Like, are things good enough that we can stay here and continue to learn, or are they not good enough on some axes that we need to roll back? The axes that we had set for ourselves were operational stability, whether it was burning out our ops teams, or is it impacting our sales too much in a way that we can measure, or is the performance on GCP not that great? The performance one is interesting because, like I had said before in my talk, like in our data center, everything was really tuned for optimal performance. Like we had the exact set of hardware that would give us the best performance for our databases, for our memcaches, for our web servers. And in GCP, it is less of like, there is less variability. Like you only have a certain class of boxes, a certain classes of CPUs. And we felt like we did a lot of synthetic testing, but that can never capture the complexity of prod. We only covered 80% of the traffic, and the other 20%, the long tail, we had no idea, or we had some idea, but not an exact idea of how that would perform. So it was like a big variable for us. But we found that the performance is actually quite all right. So all the way on the right is performance in GCP. The two blank spots in the middle are two cutover windows. But as you can see, the perf was not that bad. Like it was within bounds that we had set ourselves that this would be okay and we can tolerate this and we can make this better over time. But we need to, like, we'll continue running in GCP. So now we entered the sort of tuning phase before like the big Black Friday, Cyber Monday. There was a ton of things that we were discovering in GCP, in production. So optimizing system calls. GCP and any cloud provider is a massively virtualized environment. In the data center, we were running on bare metal. We found that if we optimized away some system calls, like it would make our performance on some key systems really predictable, like really smooth and not as jagged. So we did that. The other key win for us was MySQL in GCP had some really unusual behavior on mutexes, which was only visible when there was sufficient amount of read and write traffic to this that we were simply unable to replicate through synthetic testing. But they showed up in production, and we worked with Google engineers and internal and like DBAs and other systems-minded folks to figure this out and fix it by like adjusting kernel parameters and MySQL variables. The other thing is, again, the network showed up as a huge factor. Like Google's network is a software-defined network. It is not routers and switches in the way that it would be in a data center. And at extremely large percentiles, 99.999%, if you do it often enough and at scale, then those network jitter/variances really matter. So in the case of memcache, for example, which we use really heavily, we found that the latencies would spike from a few like microseconds to many hundreds of milliseconds, and this would matter for our application. This was another thing that we just had to go to prod to discover because we were like the sort of request patterns that prod has, was really hard to mimic in a test environment, in a simulation. But this was, again, like Google were great partners with us. Like we engaged them, they did all the packet captures, they figured out what was the issue over some period of time, and they fixed it. It was actually a bug in their SDN that we found for them.
Thanks.
So like this is roughly the timeline. Like we got through all the tuning phase, and we made it to Cyber Monday without any issues. Like we survived in slush, more than survived. Like we were able to scale up and down during Cyber Monday as we needed to in order to like manage all of our load, all of the load that was on the site. And it worked out like the way that we had hoped. So some observations from being in the cloud. Like we've been running in the cloud for about 7 months now, and we've learned some things. So long-lived flows. In the data center, again, like this was something that we did not have to care about. If a service opened a connection to another service, it could go on for weeks, hours, months, and it would not matter. But in Google's software-defined network, this was a problem. A connection can only be idle for 10 minutes before the SDN kills it. This was something that we had to discover the hard way, where we had a bunch of services that were acting weirdly. But it was something that we could adopt to, like using keep alives or using pings allowed us to work around this. But this was a thing that we had to learn, and all of the service owners had to adopt specifically to. The other, like on the plus side, live migrations, really good. If Google needs to do maintenance on a host, they will live migrate you off to another host. And this works even for like things like Memcache and MySQL, which have large memory pools and a lot of traffic. And the blip is really tiny, so like this is something that we like made our jobs really easy from an operational perspective. And lastly, infinite capacity. The cloud promises to be infinite, but at scale, it really is not.
Yeah.
What do you think, Danny?
So I can speak to that. So I think that's part of the narrative of cloud, right? Which is, I can just burst and I have all this capacity and everything I need and all the CPUs I need and all the RAM and everything is there for me, right? So that's the cloud vision, right? So, and that works, by the way, if you want like 500 cores. Sounds good. You want more, 500 cores, 700 cores, 1,000 cores? Go for it. But when you want 50,000 cores and you want it now, it's a little different. And I think when we start thinking about that, there's two layers, right? The first is people, right? We want to give you all the capacity we can do just to support your activities. But there are many other people who also want 50,000 cores of the same thing that you might. So thinking about that idea, you start to realize that, wow, it's not just 50,000 for me, it's 50,000 for lots of other large customers. And then also, it's kind of reasonable to say that hardware is still a thing that we need to buy and put in our data centers, and that takes time. That was outlined here too, right? At the end of the day, cloud is just somebody else's computer. We need more computers. So infinite capacity makes sense, but at the right scale rather than a massive one.
And like Danny and other Googlers were like good partners to help us figure out like how much heads up do we need to give them if we needed 50,000 cores when we needed them. So this was something that we had to learn. Like our cycle was a year before. Now it was much smaller. Like we could give them heads up maybe a month in advance, and we would have the hardware rather than 12 months in advance, as it was before. So coming to an end, circles of success.
Yeah, so I think we added this slide in because we wanted to call out, I think, one of the fundamental factors of a large-scale migration of a system like this, that it takes a village. So there were Googlers, a tremendous amount of Googlers who put in their time and effort to make sure this happened, and it happened pretty seamlessly, not just for Google, but really for Etsy and Etsy's customers. And then there's the Etsyans. Now what's kind of interesting is you really have these three circles, and I'll attribute this to Chris, who's in the front row here. He came up with this idea, which was there are three circles of kind of influence or ownership or impact, we'll call it, three circles of impact in Etsy. The first is kind of your core team, right? This is your squad. Not only are these people there to develop the systems and the ideas around them, but they're also on call, right? Because they have the deepest context. So that's the first kind of core, and that's like maybe 5-7 people or so. And then outside of that, as Keyur mentioned, you had a team of people who were testing the site, like going to Etsy.com when it was live at 4 in the morning and making sure that the manual testing covered all the edge cases and use cases they didn't even think of in the first place, right? These people are giving up a lot of time. They're coming up runbooks beforehand, and they're there to help and make an impact. So this is kind of another layer. And then finally, outside of that, you have this broad layer of people in the organization that supported everyone. You had management, you had teammates who took on work that other folks would say, hey, listen, I can't do this because I'm on the squad, can you help me out? Even people in security who are on the outside, actually letting people into the building at 3 a.m. Like it takes a village, and I think it's worth saying that and acknowledging that, a cloud migration, really any systems migration into cloud is best done as a team. And notably, value should be attributed to the people who did that, right? So even the security person who woke up at 2:30 in the morning to get to the Brooklyn office should be given credit because he was there also to make that happen.
All right, so as I was speaking before, we did a lift and shift, but it is not where we want to end up. We did a lift and shift for a bunch of reasons, which was to move fast and to move with confidence and to introduce less risk into what was already a fairly complex migration. But we're not we don't want to rest on our laurels. We don't want to stay there. We want to make things better. So we want to be refactoring our monolith to fit better in the cloud, to use cloud native technologies. We also want to get a good handle on cost management. Being in a data center, the cost equation was relatively straightforward. It was you buy some hardware and then you use it for 3 years, or you don't use it, but it doesn't matter. Whereas in GCP, it really matters if the box is up and running and you're not using it. And we have a lot of technical debt that we need to pay down. Not a lot of it, some of it added because of the migration, but some of it that existed way before, that we feel that we can now pay down much more effectively. For example, if we wanted to spin up new servers in the data center, we would have to follow the usual waterfall model of placing those orders early enough so that we were able to have the capacity needed to effect any kind of refactoring. In GCP, it's a lot more straightforward. You spin up some Terraform config. As long as Google has the heads up about the capacity that we need, it's there, and we're able to execute and iterate much more quickly and with way less friction. And we want to also look at our org structures. We're running in the cloud. SRE is a thing that we want to adopt. The practices around it, around building reliable systems in the cloud, that we did not necessarily need to focus on when we were in the data center. So some of the things that Etsy is working on now that we're past it.